All right, so what I do here is to work with my colleague Sodaji to give an overview about the testbed. I want to actually start with this wheel. How many of you have seen this wheel? Right? Okay, very good. Now, so if you look at, basically it's the so-called 60 wheel, come from the ITUR, right? So you kind of highlight some of the prime use cases and also overarching themes for 6G. Now, as you look at this wheel, is there anything that kind of echoes the most with you? Like, do you find like your place, or feel this is a place you want to look at? Because it actually touches on many things, right? One thing I want to just highlight for you would be, so look at, there are actually two quadrants there, right? A few. One is the connecting the unconnected. The other is, that's one of the, four overarching themes for 6G, right? The other would be the ubiquitous connectivity as one of the kind of the usage scenarios, prime usage scenarios. So that's actually, in a way, ARA is one of the power platform, I think one of the unique mission for ARA, right? That is, how do we help address the broadband divide today, right? For example, if you look at today, even in US, where the internet has started, we have about over 30% of our population don't have broadband. By broadband, that's by the, some of the numbers you see here, that's by the, like 100 meg download, 20 meg upload speed, right? That's kind of standard broadband speed that some of the federal programs are looking at. About over 100 million worldwide, over 3.5 billion people like broadband. And then for industries like agriculture, most of the places actually we don't even have connectivity, even though the future of agriculture actually depends on quality connectivity there. So therefore, there's actually a lot of opportunity for us to help contribute, right, in the coming 5 to 10 years, especially as, for example, as Mario mentioned earlier, with the release of production quality, carrier-grade open source platforms. You don't have to be in the lab somewhere, right, to some of those corporate research labs to make tangible contributions, right? Even start being a PhD student, you can actually make potentially direct impact in those space, right? So in fact, there are actually a lot of use cases, right? A lot of opportunities, even in some of the rural spaces. Here I listed some typical canonical applications of agriculture, right? That essentially touches on, the all dimension, the full dimension of wireless use case scenario you can think of, right? What's shown here is looking at the different use cases depending on their latency tolerance and throughput requirement. You can essentially, just like you may find something similar in the urban settings, you can actually find use cases that cut across all four quadrants of the potential broad use case of Internet of Things, and there's one extreme, right? Then extended reality, and then everything else in between, from videos to systems control. In fact, some of the most advanced capabilities can be best tested in the rural environment. For example, this is a figure showing kind of automated agriculture where you have drones, tractors, edge analytics come, kind of working closely together to drive the evolution of precision agriculture. This involves actually those mission critical, actual real time and also high throughput communications that's needed. And it's actually far easier to try a bunch of drones in open farmland than having to fly them in like kind of crowded urban settings, right? So in a nutshell, there's actually a lot of opportunities for us to leverage some of the agricultural rural use cases to drive, push the frontier for wireless. And here's a test bed that's for you to help actually embark on those journeys. Before I transition to some of the technical details, I just want to share with you one specific use case. This is about precision weed control, right? So for folks who may have played with gardens or even farming to some extent, you know how difficult it is to actually control weed, right? And then, so here's some data kind of, one of the use cases that the industry, together with a research community, has been looking at. How do we use drones, for example, fly drones to do scouting, right? Because most of the farms actually tend to be, commercial farms tend to be very big, right? Hundreds, tens or hundreds of thousands of acres. Especially like, for example, in America, especially America is actually where you can tend to find the large farms. So there are actually, that's where you can think of having fly a fleet of drones going out to check out where the weed are, right? And then after that, dispatch another swarm of like sprayers just to go to where the weeds, and then just do that precision kind of spraying. So it has been studied that by doing so, you could actually potentially reduce up to 90% of the herbicide use we see today, and also increase up to about 25% crop. Right? And then globally, this can lead to over close to 19 billion annual benefits. Right? Then in US alone, there has been study that if you can fully unleash the power of precision agriculture, that alone can lead to over 40 to 50 billions of annual economic benefit by itself. So by the way, if you have any questions, feel free to just raise your hand. I will be happy to take any question as we go. So ARA has been defined, essentially designed for this purpose, right? Kind of to give us a test bed, a living lab, in fact. It's more than just a technical test bed. We have all the stakeholders involved. So ARA is precisely defined to enable exploration in this agriculture and rural wireless environment. So the details actually you can find in this article. You can also just go to arawireless.org, be able to find some of the design document for ARA to understand a little bit more. Talk to us while you are here. But essentially, there are actually two overarching principles we followed when we developed ARA. One is to make sure that we actually capture real-world rural context from both deployment to operation, and also consider economics, right? How do we enable connectivity at a cost that's much lower than what's available, feasible today? Another part would be not only look at wireless, but also look at how we enable co-evolution of wireless and advanced applications. Because at the end of the day, it's going to be the application that drive the demand for capabilities that we hope to enable. So I understand that, by the way, I understand we have some folks who are actually probably have been here last year. But we also have many folks who are new, so we're going to just give a very high-level overview, and then there's going to be a deep dive starting this afternoon, right? So at a high level, this is how the ARA deployment looks like, right? At roughly speaking, we have two layers of solutions. One is the ARA Hall. This is the mesh. You kind of see the thick lines, the mesh that's centered in the city of Ames, where we are today. But we do reach out to the surrounding farms and communities. And then each one of those dots, there's actually deployment of advanced radio access networks so that you can actually connect to the sensors, drones, tractors, also buses, and so on in the field. So we also have two sites that's just for the radio access network that's deployed at one of the research farm and also the research park. This is where you can also find some of the leading kind of companies, both multinational corporations like John Deere, Vermeer, but also some of the most exciting ag-tech startups that's actually driving the agricultural autonomy today. There's also aerospace company, actually, Collins Aerospace, that's actually having lab and also collaborate with the lab too. So we have also producer farms, and also there's a US Farm Progress Show that would come here once every 2 years. For folks who may have paid attention to the wireless industry, there's a similar event that's like Mobile World Congress, right? But this will be like that but for ag tech. So next year it will be here, most likely last week of August. We will probably most likely host the next annual event together, kind of collocate the annual event with the Farm Progress Show. So if you are maybe interested in seeing some of the ag industry, you can actually mark your calendar. We will be probably plan some event there. So there are also 2 airports that's actually within the coverage range of ARA that will actually allow us to run really serious end use cases run, right? So that may require drones more than just quadrotor drones. So Dodge will actually help take us through some of the details of the platform. But essentially for the ARA Hall, this is where you can see a diverse range of platforms that's operating at different frequency band, all the way from 194 terahertz free space optical down to millimeter wave and microwave band. There's also the NEO platform, a OneWeb NEO satellite platform that's available for you to use. On the access network part, this is where you can find both state-of-the-art MIMO platforms such as those from Ericsson, but also the fully programmable SDR platform supporting open source 5G Open RAN studies, all the way from UE to base station to the core. And also this is where you can definitely try out the commercial grade Okudo Pro platform that's going to be available hopefully within about half a year or so. So in summary, ARA has been defined to support the diverse use cases you have seen earlier, but also give us multi-dimension diversity that you can leverage to build highly reliable systems. So here's a diagram kind of give you the conceptual architecture of the platform. Essentially, it captures the structure you would see in operational networks, right? All the way from the device to edge to the cloud, right? At the device level, that's where you can see some of the bleeding edge ag tech equipment being connected through ARA. We will be able to see one of them today in the field trip. And then there's actually computer resources embedded end to end from the UE to base station to the core. This is where your experiment code actually runs, right? They are essentially running in the computers and controlling the radios. And then there's kind of the access network, right? That's operating at different band from the low band to mid band to high band, and then the ARA Hall that that's also working at different frequency band. Now with these resources, we can essentially ARA does enable cutting edge research along multiple dimensions. At the lowest level, it allows you to measure the physics of wireless channels, right? This not only cover some of the popular band today, for example, in the 3.5 band or millimeter band, but also the low band TOY space spectrum for the access network. ARA is also probably likely the only public available platform today that allow you to do this wireless XHAL research at all the way from the microwave to millimeter wave to free space optical link band frequency band. So that's the channel and physical layer, right? Link layer studies. You can look at the data measurement modeling. Then there's also you can of course do system level studies on the radio access network or the XHAL systems, and also with application in the loop, right, from the UE to base station and to the core, and with application involved too, right? In speaker application, we have been actually supporting experiments in agriculture, right, by both industries and also academics here. And then there's also, we're also working with the communities. Actually, in fact, besides its many roles, one role that ARA plays is actually serving as a private network for the city of Ames. They are actually using ARA for example, for the like water safety, water system safety, management, surveillance, and also for some of the transit and public safety use cases today. So what this means is actually that as you start use ARA, as your solution get matured, you can actually have an immediate impact because there are actually users that are using ARA today, right? So there's a very smooth transition, passive transition for cutting edge research down to this early stage pilot. I think that's actually another opportunity that ARA actually offers to us, especially for experimental researchers. Soon we all love to see our results used, right? So there's actually even a direct path there. So we are not alone, right? As Dr. Shirazi and Sumari mentioned earlier, ARA is one of the power platforms, and power program in general is also one of the many cutting-edge research institute infrastructure programs and other research programs that's supported by NSF. So we mentioned the AI Institute. We'll hopefully add one more after Kevin's talk, and we'll, maybe the discussion we'll have. So far, we have been working closely with ICICO and ARA. ARA is one of the AI Institute for digital agriculture. In fact, both would actually touch on digital agriculture. And hopefully, we will be able to find ways to even work more closely with AI Edge after today. So we have also been collaborating with other community infrastructures like Communion. That's one of the NSF cloud platform. I think what this means is that as you think about the research experiments you can perform, it's not just what ARA offers. We can actually have a more or less seamless mechanism to allow you to integrate this wireless experiments with some of the cloud edge experiments that you or your colleagues may be interested in. So in what follows, I want to just kind of highlight two example experiments that just give you a flavor of the kind of research that can be done. So one would be related to the kind of work you can perform using open source 5G or O-RAN systems, right? So we do have a sandbox where that almost support all kind of most of the, if all the open source 5G / open RAN platform, right, from the open air interface to SSRAM to FlexRig. That's one of the real-time rig available today. Also, that sandbox, of course, the main utility of ARA is actually the at-scale deployment, field deployment. So that's where you can also find most of the platforms supported today. I think one thing that's added since last year was the SSRAM. We just added the SSRAM support in the field. There's also the UEs that's going to be, you can use to run together, like the cards UE to run together with the SSRAM. So I think there's also some other O-RAN platform like ST-RAN, OSA, rigs and small that I think that should be available probably in the near term. I think right now it's kind of in the sandbox settings, but we do hope to make those available to the community probably in the coming months, hopefully by the end of this year. Essentially what this enables is allow us to run end-to-end in-field and whole-stack 5G studies, right? So that allows you to change anything you want, especially for some of the more cutting-edge, really bleeding-edge research that does require us to change some of the lower layer components. So here's one example about, there has been a lot of discussion about ultra-reliable, low-latency communication And with 6G, there's a discussion about hyper reliable low latency communication. But essentially, that's actually, I think that's one field, one area that actually can benefit a lot of innovation, right? Because from the 5G effort, I think there's definitely a lot more awareness. There are also a lot more mechanisms that was built into the standard to provide support. But to bring that to reality actually does require some fundamental requires to address some of the fundamental challenges. Now, here's one piece of work that actually uses ARA to help address some of the related questions. For example, there's a question of when we think about highly reliable low latency communications, there's actually the need for looking at how can we even enable predictable control of every packet transmission, right? So for that, essentially, we need to be able to, be able to control the receiver side interference, right? So that there's actually a threshold you can actually bound that. But then on top of that, we want to be able to adapt to channel conditions at fast time scale to do intelligent transmission power control. So essentially, this is one piece of work that was done recently using the ARA platform as a testing facility. Folks interested can actually check this out. Another part I want to highlight is that's on the run side, right? And then on the backhaul, here's another study that was also completed with ARA. This is using the free space optical communication link available in ARA. In particular, we will actually go out to one of the field site today. So there's actually a link about a little over 10 kilometers, right? In fact, probably this is the only such long free space terrestrial link that has ever been deployed in a public research setting. So some figure here kind of showing you we'll be able to see some of these devices in the field, right? This is you see the custom-made free space optical telescope, communication telescope. One at the Westinghouse site, the other is at the agronomy farm, right? So this kind of showed how they are connected through the switches and routers, and then to the data center, and so that you can actually run experiments to connect meaningful data here. Now, so here's some data kind of showing because for free space optical, right, it's highly sensitive to the atmospheric conditions, right, the weather conditions. This kind of showed at the receiver side the brightness of the signals. You see when there's no rain, right, you see a bright, kind of dot. That's where you can actually communicate nicely. But then we have some rain, you could kind of get blurred. If it's heavy rain, actually end up we not be able to even see anything at all, right? So with the ARA optical platform, you can actually do detailed measurement about even like some of the specifics, like the pixel values of the communication, right? And then try to relate that to the the weather conditions. And you can actually even do fine-grained like time series analysis, right? This kind of showing some of the animations, kind of seeing how this evolves over time. Essentially allow us to do detailed measurement, right? And then, excuse me, use this to drive some of the research investigations that would be otherwise infeasible. So besides the wireless communication equipment, we do also have the state-of-the-art like weather condition measurement devices. For example, there's the disdrometer here, right? That kind of actually allows us to measure very fine-grained weather information like precipitation type. Is it rain, snow, hail? In each case, what is the intensity, the drop size distribution, velocity, and so on, right? So very detailed information you can use to actually understand the behavior of the channels. There's also rich spatial diversity. For example, in this set of figures, right, it shows the For example, in this case, at the two ends of the ARA Hall link, the rain rate at Wilson Hall and agronomy farm, right? So you can actually see there's actually a good degree of diversity in the rain rate, similarly in the humidity. Right? Essentially, what this enables us is to allow us to use spatial diversity to increase the reliability of our communications. So here's a summary of, ARA opened up to the community use about 2 years ago. Over the past 2 years, we have seen a steady increase of the usage. So here's a summary about we have folks from over close to 50 organizations worldwide and over 95 projects that are actually using this, and then about over 300 users. A map of where we are. Actually, this probably include where you come from too, right? In US. Also, we have users in Canada, Brazil, also Europe, Asia, some there. And some statistics on the number of teams, right? Number of project teams, research teams that has come to use ARA, number of users, and number of experiments, right? Also, we have seen today over actually 4,000 experiments that has been supported by ARA. A breakdown of the use cases. Actually, we do have a lot of, if you see the big block here, a lot of open source experiments that's supported by ARA. Of course, we also have the COTS platform on the both run and the X-Hall side. That's also starting. In fact, I think we see a growth of X-Hall experiments lately. So hopefully that could be potentially would actually grow over time. So before I give the floor back to Daji to kind of help you give you a virtual tour of the infrastructure, I just want to highlight that besides giving you the platform you can use to run research to get your research published, but also potentially translate to near-term kind of real-world use. We do hope to have the opportunity of working with you to highlight your work, right? So this would be on one hand would be one mechanism to help disseminate your work, but also help inspire other researchers to actually learn from your work and also use ARA. So there are two mechanisms today. If you go to the ARA website, you can actually join there, kind of go there and share your publications. Let's say if you have a piece of work that's using ARA, you can actually just click that link that would take you to a form. You can submit your information there, or you wanna, if you wanna also share your story, like some of the some of the back end story that's probably not necessarily available in a publication. You can also, we would very much love to hear from you too. So far we have featured a few user stories already, right? For example, there's this study by colleagues from University of Missouri and Argonne National Lab using ARA for rural broadband measurement. And also there's another story about colleagues from University of Victoria being able to use the OneWeb user terminal to perform the studies they could not do actually elsewhere today. Yeah, we look forward to learning more about your work and also feature your work there. In addition, we are actually, besides looking at individual research, right, we are looking at opportunities of using this tool as a mechanism to probably allow us to collaborating with that's infeasible otherwise, and look at how we can even synergize and focus on kind of bring our strengths together to push progress in some of the key areas such as AI, machine learning, highly reliable, low latency communications, and also private networks. We will have a session dedicated to this this afternoon. If you have any thoughts, please do feel free to grab us, or we'll be happy to chat. Yeah, just an overview about the program. Right after this overview, we will have dedicated talks from the community researchers. We have 4 talks scheduled. And then Cindy is going to also help us share how you can use ARA for education, not just for research, but also education. Looks like the animation went wrong, randomized. So we will have, then I think that's essentially going to be the morning session, right? And then starting in the afternoon, we're going to really jump deep into the ARA capabilities. We're going to start with tutorials, and then there's a hands-on training sessions. And then I think for some of us, especially maybe faculty members in the room, we can probably have a kind of pilot session where we'll kind of look at some of the community collaboration discussions. And then around 5 o'clock, we're going to actually head out to the field. It's actually just the right weather to go out actually at this in Ames. And then we'll come back around 6:30 or 7 for the poster and reception. Tomorrow will be mostly focused on the AraSum. That's a hackathon. Basically, you would get to work with students, colleagues from other universities to tackle some of the fun problems, hopefully, that you will be able to come up with. So with that, maybe Daji, you want to come up? We'll do a quick summary of the infrastructure, and then we'll maybe open the floor for discussion. Yeah. Let me bring up the slide. So it's okay. Well, okay.
Hey, good morning. So I'm also part of the ARA team. My name is Daji Chao, and a faculty member here with Hongwei, and so working on ARA since the beginning. So I see some familiar faces today, so that's great. Great to have you back, and some new faces too. So welcome to Ames, and Hongwei already touched upon all the different aspects of ARA. So what I want to do is just to show you some pictures. Probably that's fun to see, and as Hongwei said, a virtual tour of what we have. Some of the slides probably I would just skip quickly. We already seen that. All right. This one, okay, so many. So this one, so we have already seen the map. So what I want to highlight is the phased deployment era. So we started in 2022. So 2022, 23, that's a phase 2. Then 24, 25, that's, sorry, that was phase 1. So then phase 2. So right now we are going phase 3, right? So you see those green dots. We have 4 base station deployed. That's the very first batch of deployment for base station and the surrounding environment. We have the user equipment. So then we have those 3 big red circles. So that's the phase 2 deployment. Okay. So that's more into the even more into the rural area. You see some in the farm, some in the rural community. So that's 3 more base stations. So then right now we are doing 1 more. You see the orange dot, probably you can see here. Can you see the cursor? Yeah, over here. So that's really in the heart of the central Iowa rural community. So that's Infobunker Tower. So we co-locate with one of our local ISP providers. So that's a very interesting deployment in progress. Okay, so this slide you already saw. So that's ARA Hall, ARA RAN, 2 platform together. That's our ARA. So I'll skip this quickly. So this is about the ARA Hall. So in phase 1, so we had this one single link between the agronomy farm and Wilson Hall base station. So that one had the Aviat deployment together with ARA Optical, actually. So that's our very first try. So then second phase, we added 6 more links. So now we have really a mesh, even though the small scale, but it's each link. So you see the variable length and so on. So that's a really nice experiment platform for basic mesh networking research. So that's based on the Aviat technology. And so, so obviously diameter is tripled, and so we have mesh here, right? So that's so ARA Hall experiments are based on the Aviat that's available in the portal, so you can take a look at the example experiments there. So then use that for your research. So a little bit more about ARA Optical, right? So again, so this is the picture you saw from Hongwei's slides. So we have agronomy farm that's on the left figure. So then Wilson Hall rooftop deployment on the right. So this afternoon we're going to visit agronomy farm. So you will see the pole there and see all the base station and the telescope, everything there, right? So that's one of the 2 highlights you will see this afternoon. And so this is first of its kind of FSOC deployment outdoor, also long distance. And so far, and so other deployment, yes, you see around the world. So that's probably shorter distance at 2 kilometers and so on, for example, right? So what we are doing is trying to communicate with a really long distance, 10 plus kilometers. So even going to like a 20 kilometers, that's what we are hoping for. Okay, so that can support 16 channels in parallel. So each one right now we are using 10 gigabits per second transceiver. That's why right now it's like up to 160 gigabits per second throughput, basically between 2 sites. And so, but we are also testing with the new coherent transceivers, so possibly up to 400 gigabits per channel. So that means add up together, you can calculate that's probably can support a terabits per second sort of communication. That's extremely high. So far, so we have done many algorithmic improvement and so on. So recent measurement we saw it's about 3 gigabits per second over a single link. So that's over 10 kilometers or longer. So that's really interesting and accomplishment. So that's what we have. Okay, so ARA Optical platform also available in the portal, so you can access the ARA Optical equipment devices and do some measurement studies. So that's available too. So that's all kinds of different measurement results available there. So you can understand the channel better. So you can do interesting modeling research. So there's many possible opportunities. All right. So let's go to the ARA RAN little. So again, the same picture. So we saw here. So these are the 4 phase 1 deployment. You see here, like we have 2 poles and 2 rooftop. And for Wilson Hall in the middle, so we have this Skylark deployment with Ericsson, and as well as you see the dish and a telescope already. That's for the ARA Hall. So then another thing is on Wilson rooftop. So it's a really busy rooftop. So a lot of deployment over there. So we have this Hughes LEO SATCOM terminal there. So that's the one of the equipment. Hongwei says University of Victoria. So they're utilizing it to do some interesting SATCOM research. Okay, so we're also planning to add a Starlink SATCOM terminal as well to the same rooftop. So essentially you can do some side-by-side measurement study and comparison study too. So that's very interesting. Basically, again, so the key mission of ARA is to provide a very comprehensive experimental platform. So you can do whatever you can think about related to rural broadband, also ARA Hall or X Hall or RAN research. So that's what we strive to accomplish. So 2 more picture there. So these are the weather stations. So the top one, that's a distrometer, so it can measure really high precision information about the weather event, even the particle size and distribution. All this very detailed, fine-grained measurement data is available. So bottom one, that's just weather station, just a regular Davis weather station. But these two together, we can have a clear picture. So what is going on and the particular time instance. So to understand the weather impact on the system. Okay, so we have this pair of weather stations at every base station, essentially. Okay, so you can really have a good understanding and see how the weather impact, weather event move from one base station to another. You see really interesting observations on the impact. All right. So that's the phase one. So then phase two, we add 3 more. So these are 3 tower distribution co-located with our local community. So here's a summary of what's available on each base station. So essentially for phase one, so we have Skylark, that's for the TV white space. And for we have an SDR platform, also the Ericsson, the commercial RAN platform. Okay, so for phase two, we focus more on SDR and Skylark. That's what we have, bottom 3. And that's what we have. So overall, you can imagine, so the footprint, right? So the coverage of Skylark increased from 55 to 290 square miles. And so for SDR, so the coverage doubled. Okay, so not only the coverage increase, also we have made some progress in terms of the API, for example, more API available for running Skylark experiment on a TV white space, also for SDR. So really interesting, right? So as Hong already mentioned, so we now support both OEI and SRS RAN. So those are kind of ORAN experiment outdoors, not just indoor in the lab, it's outdoor, right? So for the our SDR base station, those kind of UE sites, the equipment size, sort of close or kind of mid-range from the base station, we can run OEI or SRS RAN. So that's basically what we see, okay? Yeah, again, so all these experiments are available through the portal. So this is just a quick summary of what's available at base station and so on. So many of these I already touched upon. Just to highlight one more thing here. See at the bottom regarding Ericsson base station. As Mari commented at the beginning of our AraFest. So right now we are supporting experiment on Ericsson commercial RAN plus the Open 5G as open source core networks. That's a very interesting integration. That's the first of its kind. So we don't see it anywhere else. So that's essentially to understand the interaction between a commercial RAN and the open source core. Right? So that's another experiment available through the portal. Right. So and we also studying. We are trying to integrate with other open source core networks as well, like Ether, SD core, the 35GC, for example. Okay, so many efforts are in progress. Okay, so UE, some picture here to show you what we deploy in phase 2. So these are new UE sites, and see we have some like a rural community, residential deployment, and so we have ISU feed mill, that's kind of rural farm industry, and also Iowa ISU bioprocessing plants, that's a kind of rural industry. So these are different locations, and so representing different types of channel condition and so on. So that's what we have done in phase 2. Okay, bottom left, that's an interesting deployment, basically adding our ARA UE box. So attach that to this Amiga robot. Again, that's something you will see this afternoon. That's in an agronomy farm. So that's the robot basically to do the precision agriculture application. So with ARA UE box attached to it, so we're basically providing high throughput, low latency connectivity. So to allow this robot can do many things that it cannot before without their connectivity. That's very interesting. We'll see the Mega robot and with some sprayer drones and so on. So that's what you will all see this afternoon field trip. All right, so so finally, have these two maps to show you. Like the bottom is the phase 1, so that's the beginning. So then after phase 2, so we obviously expand the footprint of ARA, so many more. So base station sites and the UE sites, right? So that's available now. Okay. So one thing to highlight here is the bottom left. So that's basically our new solar powered UE trailer. Okay, so that's very interesting. Again, you will see that this afternoon too. That's right now near the Curtis Farm base station. So what it does is just basically become a standalone UE unit. So you don't need a plug in the wall power. So it's everything solar powered. And so you see the next to the panel, that's our ARA UE box. So then we have this this pole and with our UE antenna mounted on top. So this is obviously it's portable. You can move around. So we plan to have a 10 or more basically. So this is one prototype we already have. So we are making a few more. So eventually we have a fleet of such portable UE trailers. So then we can move them around. So then depending on your research need or experiment needs, so we can even configure them according to certain like a topology or coverage. And so really make the whole thing is more flexible and more configurable. So that's possibly can allow even more interesting research experiments. So that's a very nice feature available in ARA now through our phase 2 efforts. Okay, so that's the map to compare, and I think that's all I have. So this one more slide just to summarize again. So what kind of resource available in the UE, and so what application it can allow. Okay. All right, so that's all I have, and so Hongwei, so maybe we can take some questions.
Maybe I'll hand this. Take this one. All right, any questions so far? Well, this is just so clear. Wait.
Yes, thank you for the presentation. I find it like really interesting. I'm just curious. So, on the application side, like computing facilities for like testing different applications, like for example, extended reality or I don't know, this kind of things. What do you envision, like to have it like on the edge? Do you have like some plan for that, or you just have the radios on the edge, or like some computing facilities?
I'll say yes, probably Hongwei, you can comment on more those, or Sarah, so you guys can't comment.
Yeah, so there's actually computers everywhere. Yeah, so there's actually edge server, right? We also have NVIDIA GPUs in some of the edge servers, so you can do those AI reasoning, right, and those kind of things too. We didn't, I forgot to highlight, actually, if you go onto the ARA website, and then there's a community menu, community events. If you look at 2023 public launch and 2024 AraFest', we have actually some ag tech demos. All of them actually need edge processing, right? Yeah, short answer is actually application. In fact, one thing that differentiates ARA from other test bed is actually the focus on application. So we have the cloud server in the data center, edge server by the base station. And then on the UE itself, we have super powerful embedded computers there. So that does allow you to run edge experiments. Yeah. Oh, glasses, that we don't have it. Maybe that's a proposal we can write together to get that. Yeah, actually, XR is something we would love to actually look into. It's just we have one piece of equipment, like the 360, like what's that called? Fizz Meta. Anyone remember the Meta gear we have? Yeah, that's one area we would love to work more toward actually. Yeah. Do you have actually some edge experiments you have in mind or?
Yeah, I mean, this telecontrol use case, I find it like really interesting, and we could use like this, for example, interfaces, like new interfaces, and being supported by AI, like to try to see how how the networking can improve this telecontrol side.
Sure, kind of, yeah. Yeah, that can be done actually. In fact. Any other thoughts? For one of the robot we're going to see this afternoon actually could be a prime use case for that. Yeah. Right proposal to NSF. They actually support experiments. Right? This will be really one of the cool experiments we would love to support. And any other thoughts, questions? Okay. Oh yeah.
Yeah, thank you for the presentation. I see that it supports the ORAN architecture and the architecture. So when you guys support this, do you guys support the white box structures that has like interface in it so that we can like implement the algorithms, or how do you guys like support the ORAN architecture, like high level, low level, like generally?
Maybe I can take this. Yeah, so in terms of ORAN support, so right now the radio, right? I mean, software is available, right? Essentially, you can run DUCU, open source DUCU rigs, and also, of course, 5G core. So the radio part, right now we only have SDR that can work with the radio. We don't have like commercial ORU that's deployed in the field. That could be something we can look at. We do have a separate commercial ORU that's through another project. When you say white box, are you referring to like commercial ORU, or you are thinking about something else actually?
Yeah, how detailed like that. I was just wondering, how much like fixed architecture supported. How freedom we will have when we want to do the experiments in the ORAN architecture.
Right.
Yeah.
Yeah, so I think for the radio side, if you want a new hardware radio, that we can work with you to deploy that potentially. But other than that, everything else is totally open to you. You can sit in your office, click a button, you can run it, right? Essentially all the way from the rig. In fact, where the intelligence are, that's where that's actually openly accessible. Yeah, I had a click a button today. Already there. Yeah. So I think we do have ORAN. I don't see Saras here. Maybe he's still late. Oh, Saras is there. I saw you stay late. Try to go. Yeah. I think we do have some ORAN experiment session this afternoon, right? Primary 5G. Okay. But we can look into that. We can change that probably. There are actually ORAN example experiments on the web. If you go to our website, user menu, and then user manual. There's a user manual. Then there's actually example ORAN experiments that kind of show you how to deploy it. Yeah.
Does ARA provide any simulated environment or a virtual environment for experiments involving UAVs or UZVs? Or how do we instantiate those environments?
Yeah, as of today, we don't have, I mean, we have computers, servers you can use. That's actually one area we hope to develop more into. In fact, there's a talk by Professor Chang Liu who's going to talk about digital twin. So as of today, has not been the focus. I think it's something we hope to support, actually, right? And there's another power test bed, air power, right? If your core interest is in June, I think they have probably one of the best immunity environment there. Yeah.
Yeah, so we are trying to provide some integrated simulation environment, for example, UAU, UGV, but with rural or agriculture applications. So that's what we've been focusing on. Actually, Sarah's probably will talk more later, right? So that's kind of a simulation environment we try to provide, but just a UAV alone, for example, those kind of research, yeah, as we said, airport probably a better platform, yeah.
One thing we have been trying in our own research is actually you use ARA to do like measurement. You can use that generate trace data and models, and then you can actually integrate that with other simulators like OS3 or like MATLAB 5G toolbox and so. That's something that's available today. Just we don't have anything that's live, like you can do the live field. And that could be some, again, another new project actually. Folks can get off the ground. That would be a good tool to have actually. Yeah.
Thank you. So I'm wondering if this the commercial base station has the true MU MIMO implemented in them, and like whether do you have like some analysis or like study on that case?
I know we have some control is going here. Not yet. There's another, we'll go back to you. So I think probably just I don't know exactly what can be, I don't quite recall.
So we have this Ericsson, obviously, GNOV, and so that base station, we have this Moshell, it's nice function or available from Ericsson. So that can allow us to do some configuration and so optimization and so on. So that's available. Probably not a fully programmable, obviously, because that's proprietary. But generally speaking, there's many parameters you can tune and run different experiments. And then plus, as I mentioned, Hongwei mentioned too. So this integration with open source, open 5G C core. So that's very interesting experiment to run too. Yeah.
So maybe just to add to that, I was hoping to go in who can give you the precise answer. But yeah, so I think there are two ways that ARA would definitely offer COTS 5G study that's not available anywhere else, right? So one is the open source 5G. I know probably at least one of us from University of Michigan has been doing a lot of 5G core research. You can actually then, that does give you that capability to integrate with the commercial RAM, right? That probably offers some opportunities that I would love to actually learn from you. But I know that's one field, one area. The other is for the RAM itself. I think we do have hooks that's going to allow you to do some configuration, like some of the control signals, potentially some of the coding mechanisms. Not allowing you to invent a new coding, pre-coding method, but allow you to choose different pre-coding method that's going to be run at the base station. Yeah, I think once Going is here, we'll make sure connect to you, and then she can probably help answer a lot more questions there.